Yes. Shima, your hand is up. So I was saying, therefore, one can conclude that the center of the circle can be got from a negative, from a negative 2g divided by 2 and a negative of negative 2f divided by 2. In case they give you a question in terms of that equation and they ask you to find the value of the center of the circle, then you divide by a negative 2 or you divide by a negative of that. So one can say negative 2g can be divided by negative 2. Another one can say negative 2f can also be divided by negative 2. All this will realize the center as gf. So in case you're working backwards to find
Excuse me, sir.
Yes, questions?
So first take to the previous page.
Okay.
The other page.
You wanted a screenshot? Tushime, your hand was up.
So on that part of finding square, I'm not getting it.
Or finding what?
From that part where you found the square root.
To find r, eh?
Yes.
This one, the beginning one or the second one?
What the second where you have put a tick.
The second one, eh? That's the second one. I was showing you how to find the r from this equation. Okay?
Teacher, can you begin from the first one?
From the first one here. Okay. I said, if you consider this circle I drew, okay, then we can have a center of the circle as GF. Then the variable point, remember I showed you here, if this is a curve at a position P, which is XY, the cow can only eat within this circular path. It cannot go beyond the distance of the rope R. Now the rope is acting as the radius of the circle. Now P being a variable point that moves all over the entire circle, though we had seen that if you consider the diameter at A, you have a coordinate x1, y1, at B, x2, y2. Now if it is any other arbitrary point, any other random point, then P will describe a random point on the circle. So if P describes a random point on the circle, that random point is xy. But still, because P is on the circle, the distance from the circle to the center is always r. Therefore, CP is equal to r, which is the what? The radius of the circle. Now, to get distance CP, you use coordinate geometry and find x minus g squared plus y minus f squared under the square root will give us r. Then you square both sides and expand. When you expand, you realize this term. So this term is called a small c, just for simplicity. But now, this small c, when you relate it in this form, you can make r the subject in case you have been given the center, you have been given the radius. I mean, you have been given the center, you have been given that value of c, you can find the radius of the circle. So you can be asked to find the radius of the circle using this relationship. That is how I came about with that square root. So Tushime, is that better? And the lady?
So that's part of coordinate. What formula?
That's part of what?
That's part of what?
Coordinate.
I can't hear you right.
I'm meaning that coordinate part. Can you explain?
Tushime, the main purpose of this derivation I did was just to show you the equation of the circle, where it comes from.
Excuse me, sir.
Yes, please. There's a lady who has asked a question. Tushime, you type your concern. Guys, can I go to the next derivation?
No.
Ask your questions then.
How is g squared plus f squared minus r squared c?
How is it C? Yeah. It is let in the standard equation. We let small c be equal to that term because it is a term of only constants. There are no variables of x and y. So we assume the whole of this is a what? Is a constant c. Are you getting my interpretation? It is an assumed constant. You're going to see in the equations because that value, the c is a value of the center. I mean, the g is a coordinate of the x coordinate of the center. Y is the x coordinate of the center. R is a figure, radius of a circle, normal radius. Yeah? So when you combine all those three figures, they should give you one figure. And that one figure, we are calling it C, a constant. That's how C comes in. Question, don't they ask us to derive? No one can ask you to derive. But in pure math, we don't just get equations and throw them there to you. As advanced mathematicians, you should know where concepts come from. Reason, you're going to land on questions where they will give you three coordinates on a circle. Then they tell you to find the equation of a circle, find the radius of the circle. It requires this knowledge, whereby if you don't know that knowledge, you might get some challenges along the way. So don't worry about the derivation. I can see, Opio, you want to cram. Okay, cram the equation. It is okay. Help me on finding the CP to Shime. Finding CP, if this was G and this was F, you assume this is the case, that this is the C, this is the P. Distance CP using coordinate geometry is square root of x minus G squared plus y minus F squared. But CP is what? Is radius. That is how I came to realize that CP. Then you expand. Okay, guys, don't worry. When you ask questions on this derivation, the first one, we might not finish the course. Okay, the alternative. Alternatively, we can get gradients. The gradient of line segments, AP. If you recall, I gave you A. You see this A? The gradient of AP can be got from y minus y1 over x minus x1. Then the gradient segment of PB will be y2 minus y over x2 minus x. But because these two lines, AP and PB, are perpendicular, when you multiply their gradients, you must get -1. So it's the definition I want to use there. So y minus y1 over x minus x1. Then the gradient segment, gradient of line segment BP is going to be y minus y2 out of x minus x2. So if this is M1, the gradient segment, then this is M2. Because they are perpendicular, M1 times M2 should give us -1. Since AP and BP, we have seen they are what? Perpendicular. Therefore, if they are perpendicular, we shall have y minus y1 out of x minus x1 multiplied by y minus y2 out of x minus x2. When you multiply them together, you must realize a negativity of 1. With this sense, you have y minus y1 times y minus y2. This should give us a negativity of x minus x1 and x minus x2. This also is another standard equation. Of a circle. Though most people talk about only the other first one I've derived, I've showed you. So especially when it comes to these derivations and these equations, people get a little bit challenged. But when numbers start flowing, you know, pure math, every time the definition complicates life, but when we bring in examples, our life becomes a little bit easier. So, can you allow me to go for an example so that people are not so bored with the different parameters they can't relate with? So, examples. The equation of the circle, given that find, says find the equation of the circle given that, given the coordinates of the endpoints of the diameter as 2, 3, and 4, 7. So they have given us the coordinates of the endpoints of the diameter as that. What does that mean? It means that this is the circle. Then the diameter here has 4, 7. Then it has 2, 3 this way. This is A, this is B. It can have a variable point P up there, X, Y. Then it also has a center, which is what? Which is GX, GF. First of all, the center is the midpoint, which can be realized from 4 plus 2 out of 6 and 7 plus 3 out of 2. Definitely our center would be, this is out of 2. It would be 3, 5. So that is the center. If I've got the center, I can find the radius. The radius can be found from a half. A half of what? A half of the AB. But I can also get it from AB, I mean from CB and from SC. So the radius can be the square root of 7 minus 5 squared plus 4 minus 3 squared. This will give me 2 squared, which is 4 plus 1. Then the radius is square root of 5 units. So the equation of the circle, if you see P, you see P is XY. So this R should be the same as this R, should be the same as that R. Therefore, if I consider P or CP, CP will be the square root of X minus G squared plus Y minus F squared is equal to the radius. Now this will give us X minus, what value of G did we get? G we got 3, F is 5. Yes, please.
Chair is requesting take a screenshot.
Okay, let me go back.
Thank you, teacher.
Okay. So with this, you can see that X minus 3 squared plus Y minus 5 squared is going to be equal to 5 when you get the square root, squares on both sides. You square on both what? You square on both sides. So with that sense, This is also one format of writing an equation of a circle. So this is also an equation of a circle. And this equation clearly tells you the circle is written as x minus g squared plus y minus f squared. This is always equal to r squared, whereby the term you have here is the square of r. The term you have here is the y ordinate of the center. The term you have there is the x ordinate of the center. Now, which can be expanded further. Now, if one wanted to use the method of the gradients, or if you go back to our circle here, line segment AP, then we have AB. Remember, we say these line segments make 90 degrees. So the gradient of AP will be y minus 3 out of x minus 2. Then the gradient of BP will be y minus 7 out of x minus 4. This is because B was 4.7, A was 2.3. So when you get AP, it will be y minus 3, then x minus 2. Then for BP, it will be y minus 7 out of x minus 4. That's how I've realized those equations. But because these two are perpendicular gradients, then y minus 3 out of x minus 2, when you multiply them together, you should be able to realize y minus 7, x minus 4, and when you multiply them, they should give you negative 1. Therefore, if they give you negative 1, how can we go about it? We shall have y minus 3 times y minus 7 is equal to negative 1 into x minus 2 and x minus 4. Further expansion, y squared minus 7y minus 3y plus 21 is equal to a negative into x squared minus 4x minus 2x plus 8. Further expansion, you realize y squared plus x squared. This is a negative 6, means a negative comes in front, positive 6x. Then this one gives us a minus 10y, 21 plus 8, you get plus 29 is equal to 0. This 6 was having a negative, so it's a negative here. So this becomes our general equation for the circle. Now remember, I told you if you want to get the center, you come and look at the coefficient on x, which is negative 6, and divide it by negative 2. Then the coefficient on y, which is negative 10, and divide it by negative 2. You realize that the center is still 3, 5, which we got here and there. Then other people who don't see also this equation, you can expand that equation. So from x minus 3 squared plus y minus 5 squared is equal to 5. When you expand, you realize x squared minus 6x plus 9 plus y squared minus 10y plus 25 is equal to 5. You realize x squared minus 6x, okay, plus y squared minus 10y plus 29 is equal to 0, which is the same equation. So one of the conditions which is very vital here, we should understand the circle, is that these two highest degrees of x and y, they should have the same coefficient. If y squared has 2 and x squared has 3, it is not a circle. But if y squared has a 2 and x squared has a 2, it is a circle. So a circle has the highest coefficients on x squared and y squared the same, as we shall see in further derivations of circles. Any other concern here on this equation? Or I give you a number to try out. How do you see? For example 2. The points. Please, if you have a concern, you raise it. 8, 4, and 2, 2 are ends of the diameter of the circle. Find the coordinates of the center of the circle, comma, the radius of the circle, and hence deduce the equation of the circle. Please check that one out. Try it out now.
Excuse me, sir. So do we have to expand the first equation? Excuse me, sir.
Yes, Tushime, what you're saying is true, it is a circle. The only varying equation which can be similar or looking a little bit alike is the equation of the ellipse. The ellipse, we shall see later. The ellipse looks like this. X squared over S squared plus Y squared over B squared is equal to 1. But when you cross multiply, you realize AX squared plus B squared Y squared is equal to S squared B squared. This still confirms it is not a circle. That becomes an ellipse whenever it is S squared plus X squared times B squared Y squared. As long as the coefficients are not the same, it ceases being a circle. It becomes something else. So Tushime, you're right. Every time we have X squared and Y squared having the same coefficients, it is a circle. The lady had a question. I did not get her. Was it Adnan?
So the first equation, we have to expand it.
Pardon?
Or we can like that. This equation
Of x minus 3 and y minus 5. We have to expand. Yes, we have to expand. In most cases. The reason why we have to expand or why we expand, sometimes we need the expansion to get us other items. Okay, that is why we expand. But if there was no other items asked for, you can stop at that, at this box where I have the tick here. You can stop here. But if there are other items needed, you need to expand as far as here. Actually, I had not showed you. Now, our C is 29 here. Our G was 3. Our F was 5. Let us check the radius. I told you radius is square root of G squared plus F squared minus C. When you check them out, what do you realize? 9 plus 25 minus 29. What answer do we get? We get root of 5.
Root of 5.
So it's the same. So that's the relevance of this idea I showed you. So please try out that example. Give me the answers. I advance to other examples.
Sir,
Yes, please.
excuse me, sir.
Yes, please.
I have y squared plus x squared minus 6y minus 10x plus 24 is equals to 0.
Very correct. Which method have you used? Gradients or variable point?
Gradients.
Okay.
Gradients.
No problem. It's correct. The rest, how far? I've not had any girl get the answer.
Excuse me, sir.
Yes, please.
Must I have x squared plus y squared minus 6y minus 10x plus 24?
Very correct. What is the
And
radius
center
you
I have square root of 10 units.
Very true. Center?
5, 3.
Very true. Thank you so much. Hope everyone has that. The girls, do we have those answers? None of you has given me one. I'm waiting for at least a lady to give us an answer.
Excuse me, teacher.
Yes, please.
I've gotten y squared plus x squared minus 10x minus 6y plus 24 is equal to 0.
That's 24 is equal to 0. Correct. Elizabeth Magara is asking, what are we learning? Elizabeth, you're welcome. We are learning conic sections. Now, who has put for her the equation of a circle? Can you imagine? For that, Steve. Really, your friend asks that and you put an equation of a circle. Yes, Elizabeth, we are learning conic sections, and we have agreed that conic sections include the following. If I return you to our first page, conic sections include the following: a circle, a parabola, ellipse, rectangular hyperbola. And members agreed that we start with a circle. So if for you had covered a circle, take it as a review. If you had not, then still we are having it as our first definitions in conic sections. And we have seen the general equation of a circle can be in this format. Even the logbook has the equation. So people who are worrying, don't worry so much. Even the radius can be got from this relationship, where this C is a constant which merges all these squares. Then Elizabeth, also we saw that we can use the method of gradients, which gradients also gave us a diameter, AB, and you have a variable point P up here. Then from circle properties, AP and BP form 90. So they are gradients. When you multiply it, you get -1. So we are using those concepts. But with time, you'll see what we have. Now, there is a third definition we need to have here. Getting the equation of a circle. Equation of a circle through 3 points. When a circle passes through 3 points, what does it mean? Here, all the 3 points lie on the circle, first of all. That is one thing we should know. So if all these 3 points lie on the circle, therefore, generate 3 equations in terms of G, F, and C, using the points given, and then solve them simultaneously. So this one, the method of the gradient, we can first pose it. Unless if the question sets a diameter. They don't set a diameter, then the standard equation of the circle, which is in terms of G and C, is better for use. So you can say the 3 equations, the 3 points lie on the circle. And therefore, generates 3 equations using the standard equation of the circle. And then solve them simultaneously. Now, when you solve them simultaneously, you find the values of G, F, and C. Hence, you will deduce the equation of this circle. Now, the standard equation, remember, is x squared plus y squared minus 2gx minus 2fy plus c is equal to 0. So for those of us who do not recall what the standard equation is, so whoever was asking me, why don't we expand? Why do we expand? We are going to see the reasons why we expand. So question, of course, if I give 2 numbers, one is for the teacher, one is for the learners. Find the equation of the circle passing through the following points. A, 3, 1, 8, 2, and 2, 6. B 0, 0, negative 1, 3, and 2, 6. Which one should the teacher handle? What, the first one, the second one? Of course, the second one will be yours. Eh? So tell me which one I should handle.
First one.
First one. Okay, if I handle the first one, this is my assumed circle. If this is my circle, then my point 31 can be here. Then my point 82 can be here. Then my point 26 can be somewhere around here. Anywhere. What does the standard equation state? It states that x squared, who can state for me the standard equation of the circle? Aisha Abdallah. Aisha, you there? State for me the standard equation of the circle.
X squared plus y squared minus 2gx minus 2fy plus c is equal to 0.
Thank you. So when I substitute the first point at 31, we shall have 9 plus 1 minus 6g minus 2f plus c is equal to 0. This will give me c minus 6g minus 2f plus 10 is equal to 0. So this clearly can give me 6g plus 2f minus c is 10, equation 1. Okay. Yep, is that fine? I have substituted 3 and I have substituted. Now, sometimes you'll find some books having the following. You will find them having a plus where they have the equation of the circle. And if they have there a plus, remember when you're finding the value of the center, you have to divide by -2. So if it has a plus there straight away, the g's were negatives. Yeah? So one has to have that in mind. How about at, yes, Habib?
Teacher, when they ask us to find the equation of the circle, is it okay if I just substitute and I get the answer directly?
It is very okay. But if and only if you have the center, you have the radius. Those are the two main things you need. Okay? And now these points, they never told us that they are cutting through the diameter. They are just random. So whatever you're saying, Habiba, is true if and only if they have given you the center, you have the radius, you know it, then you can use the other equation to get the value of C, then you can use the G and the F and the drop. Okay?
Yes.
Now we shall have what here? We shall have 4 plus 36 minus 8G. We shall have minus 8G. F is what? I mean, Y is 6, so minus 12F plus C is equal to 0. You will see that we have 8G plus 12F
minus 4
minus C
minus
is
4J.
Minus 4G. Oh, yes, thank you. Is equal to 40. Then furthermore, at 8, 2, we shall have 64 plus 4 minus 16G minus 4YF plus C is equal to 0. Then we shall have 16G plus 4F minus C is equal to 68. Experts, because did you do echelon row reduction? Eh? Did you study echelon row reduction formula?
No.
Not yet. It's a formula for solving three simultaneous equations with three unknowns. When the number is secondary like this, avoid using echelon, which is very long. Eh? So you can use elimination by saying, for example, Roman 1, this is Roman 3. Roman 1 minus Roman 2. Roman 1 minus, okay, Roman 2 minus Roman 1. You shall get a negative 2G plus 10F is equal to 30. Equation star. Then also eliminate Roman 3 minus Roman 2. 16G minus 4G, you realize a 12G. 4F minus 12F, you realize a negative 8F. 68 minus 40, you realize a what? A 28. Equation start. With this, when you divide this one by 2, you get G a negative plus 5F is equal to 15. When you divide this by 2, you realize a 6G minus 4F is equal to 14, taking you to 3G minus 2F is equal to 7. I can make G the subject from this upper one, and I say thrice into negative 15 plus 5F minus 2F is 7. Negative 45 plus 15F minus 2F is 7. 13F is going to be equal to 52. F is what? 4. Yes? F is 4. What is Y? I mean G. If F is 4, G is going to be?
Negative 5.
G is going to be?
Negative 5.
Negative 5.
Yes.
G is negative 5. Are you sure? G is negative 5 and 4 is positive. F is positive.
It's positive 5. It's positive.
It's positive. That should be positive. How were you getting the negative? Did you get a negative F? Of course, you can put these things in a calculator. Guys, investigate, because I'm having a problem here. The answers I expect are G is positive, negative, and F is also negative. But I'm doubting, how does it come about? When I derived this equation, where did I comment? We are right. So we are getting a what? A positive, eh?
Yes.
Okay, can you find C? So since we have got G is 5, F
Teacher,
is
can you
what?
please go back to the previous page? Teacher, thank you, I'm done.
So we are saying G is F, G is 5, F is 4. And this takes us to, if F is 4, we can find the radius. But before we find the radius, we can find C. Remember, we had an equation of this kind. We had 6g plus 2f minus c is equal to 10. 6g plus 2f minus c is equal to 10. So this is 30 plus 8 minus c is equal to 10. C is equal to 28. And now the c is consistent. Okay, so if I have c, I can find r from g squared plus f squared minus c. So r would be the square root of what? R will be the square root of 5 squared plus 4 squared minus 28. This is 25, which is 41 minus 28. 16 minus, you get 12, 12 minus 25, you get 13. This is going to be square root of 13, is the radius. So the general equation will become x squared plus y squared minus 5x minus 4y plus 28 is equal to 0. Now the beauty with this, according to the book which I have here, they had a general equation of the circle in this form, that also x squared plus y squared plus 2gx plus 2fy plus c is equal to 0 is a true equation. But in this case, the center of this equation is a negative 2g. When it is a positive here, the values of g are negatives, and the values of f are also what? Negative. So don't get worried when you find such an equation defined. You just have to substitute correctly, and the values will always correspond. So everything else is the same according to this book. And I had only got different values of f and g. For them, they got f is negative and f is positive. Now, when they substitute also in the equation, this one, which has positives, they get the same answers. Because if for them, their g is -5 and their f is -4, you still see that you have the answers x squared plus y squared minus what? Minus 8y minus 8y minus 10x plus 28 is equal to 0. Actually, I forgot to multiply by 2. There is a 10 here. There is an 8 here. Because the general equation, that's why you have to write down these things. Minus 2gx minus 2fy plus c is 0. So that you see clearly what you're substituting. So I had missed slightly. So we end up having the same equation, whether I've used it with minuses or I've used with additions. But remember, I've told you if additions, it means the center has negatives. If subtractions, the center has what? Positives. Do you have any question there? So one of the challenges there is to solve simultaneously. So the second number is yours, guys. No questions. And you have it now. We have around what, 20 minutes. But not all those 20 minutes are yours. You have around 5 minutes. But can we start other items? So others are coming in as applications. But applications require you to know the equation of the circle. Then I'll also show you how to work backwards. Okay, I'm going to conclude with that. You do this, or you'll do this number later. Let me conclude at once. How do you see? Yeah, let me conclude at once. Now,
We do it later.
Yes? They can ask you to find the center and radius of a circle from the general equation. They can ask you that hey, we want you to find the center. We also want you to find the radius from a given equation. Now, when they set such a question, how do we go about it? This is how we go about it. For example, I have x squared plus y squared plus 6x minus 2y is equal to 0. The question even can be like this without the c. Now, the first thing is to connect the x together and the y together. So x squared plus 6x plus y squared minus 2y is equal to 0. Then we need your knowledge of completing squares by saying x squared, yeah, plus 6x plus half the 6, square it, you get 3 squared. Subtract by itself, plus y minus 2y plus half this, you get 1 squared minus 1 squared is equal to 0. I expect you to be very good at completing squares now, because you are at the climax of advanced mathematics. So with that, you will see that you have x plus 3 squared plus y minus 1 squared minus 9 minus 1 is equal to 0. With this, you can conclude that x plus 3 squared plus y minus 1 squared is equal to 10. Remember, I told you the equation can also be in the form x minus g squared plus y minus f squared is equal to r what? Squared. Therefore, in this sense, g is equal to a negative 3. Then f is equal to a positive 1. Then the radius is equal to root of 10. So the center becomes negativity of 3 and 1. Another person who is very smart can see from here, from this very equation, and say, we always get the center from the coefficient on x, which is 6, divided by negative 2. The coefficient on y, linear y, which is negative 2, divided by negative 2. Then this smart student will say, may don't waste time. The center is negative 3, 1. Hashtag solution. Is enjoying the number. Now, because there is no c, this student also knows that, okay, r is always got from the square root of g squared plus f squared minus c, which is going to be the square root of 9 plus 1 minus 0. This student will confidently get r as root of 10. Either this lower method or the other upper method. So the completing squares, I know mixes people very well. So, but I had to show you. Okay, so whatever you find comfortable is what you should go for. So they can ask you to use the method of completing squares and go ahead and find the radius of the circle and the center of the circle. Now, let me use one which has a constant c. This one never had a constant c. Let me use one which has a constant c, and we see what we have. The second illustration on this, if I have x squared plus y squared plus 2x plus 4y minus 12 is 0.
Could you go back to the previous screenshot?
You want to take a screenshot? Okay.
Thank you, sir.
Welcome. So I also wanted to look at one which has coefficients which are not 1. And I show you how we handle. Those of us with question banks, if I can proceed, visit UNEB. Help us post these numbers. UNEB 2018, number 5. UNEB 2017, number 10. UNEB 2014, question 10. UNEB 2008, question 9. UNEB 2006, question 13. UNEB 2005, question 9. UNEB 1999, question 9. Those are very sensitive numbers on circles, though they might have some other items we have not yet discussed, but let us have them ready. Just in case I reach a point where they are being asked about, I can always go through them and we become steady machines. Okay, if that is the case, now let us proceed and I show you how this number can be done. The same thing is first collect like terms. You get x squared plus 2x plus y squared plus 4y minus 12 is 0. Complete squares for both of them. X squared plus 2x, half the 2, you get 1. Square it, subtract by itself. Plus y squared plus 4y, half the 4 plus 2, square it, subtract by itself. Minus 12 is 0. So this will give us x plus 1 squared plus y plus 2 squared minus 1 minus 4 minus 12 is 0. So x plus 1 squared plus y plus 2 squared will give us 17. So the center is -1, -2. The radius r is root of what? 17. Hence, you would have handled the question. There is one special example I wanted to look at. I can't find it. I wanted one which has coefficients which are the same other than 1. Okay, let me pick any. I pick any. Maybe if they have given us 3x squared plus 3y squared plus 4x minus 6y plus 10 is 0. Then they ask you to find everything about the circle, center, radius, you know. The first thing you do here is to divide everything by 3 and realize x squared plus y squared plus 4 over 3x minus 6 over 3y plus 10 over 3, yes please, is 0. Yep. Someone say teacher.
Yes, teacher. Why?
Why? Why do you divide by 3?
Divide by 3.
It's because I want to create a coefficient of 1 on the highest degrees of x and y. Because I need to create these as 1s.
I'm saying that. I'm saying that. Why do you divide by 3?
And I divide by 3
yes.
So that these ones become 1s, so that I can easily carry out completing squares.
Is it okay?
Have you got it?
Yes, teacher.
So x squared plus 4 over 3x plus y squared minus 2y plus 10 over 3. Eyes open because action of algebra is required here. So algebra will call for x squared plus 4 over 3x, half 4 over 3x, what do you get? 2 out of 3, square it, subtract by itself. Completing squares. A plus, I'll need a lot of this knowledge because it is also coming back in ellipse. So please, those of us who are not comfortable here, better reactivate yourselves with completing squares. So we shall have y squared minus 2y, a plus 1 squared minus 1 squared, a plus 10 all over 3 is equal to 0. With this, I'll realize x plus 2 out of 3, close the bracket, to the square, a plus y minus 1, close brackets, to the square, a minus 4 out of 9, a minus 1, a plus 10 out of 3 is 0. Therefore, I have x plus 2 out of 3 to the square plus y minus 1 to the square. This will give me a minus 14 out of 9, which will call for a positive 14 out of 9, a minus 10 out of 3 on the right-hand side. With this, I'll have 14 minus, I've got problems now. You know the number, I've just got it from my head. Now it has become a negative. But it's okay. I just wanted to show you the concept. Hope you've got the concept that in case the coefficient is not 1, you always have to first divide off. Okay? Because it is giving us a complex. I'm seeing a complex being smelled somewhere, which is impossible. Yeah? This radius can't be a complex. So x plus 2 out of 3 to the square plus y minus 1 to the square would give me 14 minus 30, negative 16 out of 9. It would have been very okay if it was positive. The square root of this would be 4 out of 3. But anyway, this is not possible. Just know, if you ever do a number on a circle and you get a radius with this, which is a complex, which is a negative, it means r squared is equal to a negative 16 out of 9, which will give you a complex root, which is impossible for the circle. The circle is real. It has no component, but it can be a complex root. We can get a locus of a circle in complex numbers when you place plotting locus of a root, of a complex number. But if it is a real circle on a real plane like this one, you can't get its radius as a negative. But the concept is, what I wanted to show you is, when we have coefficients which are not 1 on the highest degrees of x and y, we first divide through by that what? By that coefficient. Hope that one is very clear. Has everyone got that? These other parts are what we have been doing before. Okay, if no further questions, whoever wants any page, let me know. I flash back, you take the screenshots. Yes, please.
Teacher, that page before.
Okay, there you go.
So when you're completing squares, where does the variable of x go?
When you're completing squares, where does the
variable of x go?
Where does the variable of x go? Of x squared?
No, like the x squared. Okay.
Give me take a look at like this one. Ask from this number.
Where does the 2x go?
Where does the
2x and the 4y.
Okay, I've understood what you're asking. The reason why we are completing squares, we are factorizing. So we go back and ask ourselves, what linear function was expanded by a square to realize what we have? That is what the purpose of the completing squares is. So if you have x squared plus 2x plus 1, at this level, you should be knowing it comes from the expansion of this. At this level, everyone should know. If it is x squared minus what? There was a minus somewhere. Okay, minus 2x plus 1. You should know it's coming from x minus 1 expanded. So we work backwards and come back to this position. Okay? So ideally, we are working backwards by factorizing using completing what? Squares.
Yes, thank you.
Welcome. Any other question? I know economics has signed in. Anytime, we still have 6 minutes, but anytime you can jet in. But before you jet in, if there is no concern, allow me end the lesson, but if there is, please raise it before I end. Hope the other lady took the screenshot. Did you?
Please, teacher.
Yes, please.
On that point of completing squares, I'm confused. I'm confused on that step.
You are confused. The method of completing squares states that if I have x squared plus 2x, you have this 2, the coefficient on linear x, then square it, then subtract by itself. Ideally, you are introducing what we call a useful zero. So when you simplify, this gives you x squared plus 2x plus 1 minus 1 squared. But this 1 squared here, this comes from x plus 1 squared. So these ones, you take them and merge them with other constants. Then this will give you the value of g as -1. So please practice completing squares. That means go back to senior 2. Get senior 2 books. I think there's a factorization I did for senior 5. Go to my YouTube channel, look for completing squares. Using factorization, using completing squares. I have discussed that with the new senior 5s. It is recent. I uploaded it, I think, last week. Go and review that lesson. Perhaps it will help you get to remind yourselves how we complete squares. Any other concern? If no concern, hey, there's someone in the chat. Thank you very much, teacher. Okay. Have a good day. Hey, people are just saying bye already. Okay, bye-bye.